What is an air conditioner? Air conditioner is a device used to cool and dehumidify indoor air. It works by removing heat from the inside of a building and releasing it outside, thereby lowering the indoor temperature. By utilizing the law of thermodynamics and applying the refrigerant cycle as a method of analysis, we can take a closer look as to how an air conditioner works. Type of air conditioner. Firstly, monoblock. Monoblock air conditioner are single unit system where all components, compressor, condenser, and evaporator are housed in one unit. These units are typically portable or window mounted. Second, split system. Split system consists of two main components, an indoor unit and an outdoor unit. The indoor unit contains the evaporator coil and the fan, while the outdoor unit houses the compressor and condenser coil. The units are connected by refrigerant pipes and electrical wiring. Third, multi-split. Multi-split systems are like split system but with multiple indoor units connected to a single outdoor unit where each indoor unit can be controlled independently. Next, general components. Evaporator coil located indoor, the evaporator coil absorbs heat from the indoor air. Condenser coil located outdoor, the condenser coil releases absorbed heat to the outside air. Compressor pumps refrigerant through the system, increasing the refrigerant's pressure and temperature. Expansion valve regulates the flow of refrigerant into the evaporator coil, causing it to expand and cool. Next, refrigerant, the working fluid that circulates through the AC system, undergoing phase changes to absorb and release heat. Fan, circulate indoor air over the evaporator coil and outdoor air over the condenser coil. Thermostat, sense indoor temperature and control the AC unit's operation to maintain the desired temperature.
These are the theory behind air conditioners. Based on the first law of thermodynamics, this law, also known as the law of energy conservation, states that the energy cannot be created or destroyed, only transferred or converted from one form to another. In an AC unit, electrical energy is converted into mechanical work by the compressor, which then drives the refrigeration cycle. Based on the second law of thermodynamics, this law states that the heat naturally flows from a hot object to a cold one. In an AC unit, the refrigeration cycle enables the transfer of heat from a cooler indoor environment to a warmer outdoor environment, effectively moving heat against its natural flow. Based on the second law of thermodynamics, this law states that the heat naturally flows from a hot object to a cold one. In an AC unit, the refrigeration cycle enables the transfer of heat from a cooler indoor environment to a warmer outdoor environment, effectively moving heat against its natural flow. This is the formula used for application of air conditioners. This is coefficient of performance, COP. COP is a ratio of useful heating or cooling provided to work required. For AC units, the COP is calculated as the cooling output in BTUs or watts divided by the electrical energy input.
Refrigeration cycle analysis of air conditioners. Here we can see a diagram of the refrigeration cycle. The primary purpose is to remove heat from a space to maintain a lower temperature within that space. Here it can be seen that the cycle generally comprises of four main components. So there's an evaporator, compressor, condenser, and an expansion valve. Starting with the first component in the refrigeration cycle, the evaporator coil. So the process undergoes evaporation, where the lower pressure refrigerant absorbs heat from the indoor air in the evaporator coil, causing it to evaporate, thereby cooling the air. And then it enters the compressor, where it undergoes the compression process. So what it does is the compressor raises the pressure and temperature of the refrigerant vapor. Afterwards, the refrigerant enters the condenser coil. So the high pressure refrigerant releases heat into the outdoor air via the condenser coil and then condensing it into a liquid. Then lastly in the cycle, it enters the expansion valve where it undergoes expansion. So the expansion valve reduces the pressure of the refrigerant, thereby cooling it further before it returns to the evaporator coil and restarts the cycle. Here is a pH graph of a refrigeration cycle. So we can see that at point 1, it starts the compression process where it goes from a saturated vapor to a superheated state. So here there is an increase in enthalpy, a bit of increase in enthalpy and pressure. Afterwards, it goes into the condensation process where the refrigerant rejects heat but maintains the pressure to be constant. And then at point 3, it enters the expansion valve where it is an isentropic process, but there is a decrease in pressure. And then entering the evaporation coil, it maintains the pressure but absorbs heat from the space that we want to be cool. Here is the TS graph for a refrigeration cycle. More specifically, the Carnot cycle or the reverse Carnot cycle, since it's a refrigeration process where the absolute temperatures are important. So it concerns the isenthalpic and isothermal processes used in Carnot calculations where the absolute temperatures are important. So we can see at 1 to 2, the temperature is constant. 2 to 3, the entropy is constant. 3 to 4, the temperature is constant but higher than before. And then 4 to 1, the enthalpy is constant but decreases in temperature. This is the TS graph for a refrigeration cycle in a realistic case. So from 1 to 2, it undergoes a compression process where it is nearly isentropic with an increase in temperature and pressure. So here we see that the line is nearly vertical, moving slightly to the right, indicating an increase in temperature and a slight increase in entropy due to real-world inefficiencies during the process. And then from 2 to 3, the refrigerant undergoes heat rejection at constant high pressure. So we can see that the line slopes downward and to the left, indicating a decrease in temperature at constant high pressure. And then from 3 to 4, it undergoes expansion. So it is a nearly isentropic process with a decrease in temperature and also pressure. So the line moves slightly to the right, downwards, representing an increase in entropy with no change in enthalpy. And then from 4 to 1, the refrigerant undergoes the heat absorption process at constant low pressure. So here we can see an almost horizontal line to the right, indicating an increase in entropy as the refrigerant absorbs heat. Coefficient of performance, or COP, we can use it to analyze the performance of the refrigeration system. So for a COP of less than 1, it indicates that the performance is inefficient given the work we put in. When the COP is equals to 1, it indicates that the performance is nominal, where the work in and the heat into the system is the same. And then for a COP of more than 1, it indicates that there is an increase in heat into the system given the work put into the system, meaning a more efficient and favorable performance.
Firstly, the addition of an inverter. Inverter technology can be used in air conditioners to help regulate the speed of the compressor in an air conditioning unit. The compressor speed is adjusted based on the temperature conditions, which enhances the overall efficiency and performance of the air conditioning system. Next is utilizing different refrigerant. Besides using R410A, R32 is more efficient and has better heat transfer properties compared to the commonly used R410A refrigerant. Next is focus on noise reduction. By improving the sound insulation and design of air conditioning components, the noise level can be effectively reduced, leading to a more pleasant and comfortable user experience. Lastly is improved sensor-based control of air conditioner. Sensor can be used to monitor various factors such as temperature, humidity, and occupancy in the air conditioning system. By utilizing these sensors, the air conditioning system can adapt its operation to the changing conditions. This adaptation of the air conditioning system's operation based on sensor data can enhance both efficiency and enhance user experience. To conclude, the air conditioner is a complex device that works by removing heat from the inside of a building and releasing it outside, thereby lowering the indoor temperature. There are several types of air conditioners, each with their own unique features and components, where the key components include the evaporator coil, condenser coil, compressor, expansion valve, and refrigerant. The theory behind air conditioners is based on the first and second laws of thermodynamics and heat transfers, while coefficient of performance is a measure of an air conditioner's efficiency. By utilizing the refrigeration cycle, we can better analyze and improve upon the working mechanism of an air conditioning unit, hence its importance. Ongoing research focuses on ideas like adding inverters, using more efficient refrigerant, reducing noise, and implementing sensor-based control system to enhance efficiency and performance of the air conditioners.